right, so as you can see, this is the paper that you guys are going to need. I want you to be sure that when you take your paper, that you trim it down all the way to the very edge of these letters, so that you will be able to close your, and I have quite the crooked thing there, but I can straighten that out, but you'll be able to close your foldable in such a way that the words will be readable. It'll be directly proportional, inversely proportional, and non-proportional. I was shooting a video. You can see I'm going to crease it right here. I was shooting a video earlier, but there were so many interruptions on the intercom that I quit doing it. Mine is going to be crooked. Yours will not be. Here's the video one that I started. Again, I'm folding it by like the word miles, and I'm folding it right on the edge of the graph here. You can see that. And then it folds and makes a nice one. I did not want to ruin another foldable, so this one is crooked, but it's the one that I'm going to use as your teacher, so I don't use a good one that you guys can have. I'm also going to have some colored pencils. Again, you don't need to have those things. I like color when I do my notebook, and so I'm going to be talking about proportional, and I will be using the orange. I'm going to be using yellow when I talk about the inversely proportional, and I'll be using green when I talk about the non-proportional. Just again, because I like color. When I'm done, I'm going to snip just like these little closet doors so that I can open them as we go. Let's talk about proportional. Again, that will be in the orange for me. We've already discussed how proportional relationships on a graph are when the line goes through the origin here at 0, 0 and is straight. So a straight line is called linear. So the line goes through the origin, which is point 0, 0. And it is linear. Linear means it's a straight line. So, pretty simple. How we can look at a table and know if it's a proportional is using this formula. If the constant here is always y over x. So, looking at my chart, in 1 hour, I drove 30 miles. So, y was 30 miles in 1 hour, so my constant is 30. If this is a truly proportional, then I should be able to divide y by x, and get the constant every time. It should be the same number. It is a proportional number, so those two proportions are equal. So 30 over 1 is 30. 60 over 2 is 30. 90 over 3 is 30. And 120 over 4 is 30. Again, I'm simply dividing y by x. So any of those numbers would work. So let me just pick the example of 90 by 3 is 30. This is a good time for me to also remind you that we use the cursive K and we mean the constant. Another word for that, the constant of, this is a big word, proportionality. That means all of these are in proportion. They're all equal. It's also called the unit rate. We just take away the labels, like miles per hour, and we plug in the 30 in the equation. It's also sometimes just called the rate, and next year you'll call it the slope. So those are just different examples of what we call the constant. Okay? Again, the constant is denoted with a K, even though it's spelled with a C. It is really just the unit rate, and it's the number being multiplied. In your examples, you may have other letters here Doesn't always have to be a y and an x and a k. You're not going to necessarily see that, but it's always going to be a constant rate that's being multiplied. Like I drive 30 miles an hour, or there are 12 inches in every foot, or I make $10 an hour babysitting. Those unit rates. Those are all proportional. So, directly proportional. Let's talk about inversely. Let's make it simple, guys. With the inverse, instead of saying y divided by k, we have to multiply our x and our y. Okay? So when you're multiplying 1 times 16 and getting 16, and 2 times 8 is 16, and 4 times 4 is 16, and 8 times 2 is 16, and 16 times 1 is 16, when you're multiplying it straight across, that tells you, hey, that's the reverse of dividing it. That's the inverse. Okay? So remember, inverse is when you multiply your table out to get the same rate every time. On a graph, it's easy to tell because on your graph, the line curves. Okay? It does not go through the origin. It is not a straight line. And, of course, the x is at the bottom. If x is at the bottom of our equation, it's inverse. So, let's remember to label. Inverse is the curve. Proportional, straight line through the origin. Okay? Finally, let's talk about non-proportional. Non-proportional. You know what, guys? It was a straight line, but it is not through the origin. Nope. It hits somewhere else. Then it's a straight line. So it does not go through the origin. And we don't have a pattern. We're not multiplying or dividing our x and y when we do our non-proportional. And we will have a plus or a minus. You'll have plus a number or minus a number, like y equals 3x plus 4. If you've got that plus in there, it is non-proportional. You need to remember that, non-proportional. So, I've kind of divided up my information. I think you're going to be good to go, guys. Y equals kx. That number in front of x is your constant. You can tell by looking at a graph if it's a straight line through the origin, and if you divide y by x, you get the same number. It's an inverse relationship if x is at the bottom and it curves, or the table is multiplied straight across. It's non-proportional if you have a plus or a minus, and it does not go through the origin, and you don't have a pattern. Anyway, take this, fold it up, put a little bit of glue on the hands and feet, just a little dot, and this will be page 26. Good job, guys.